This is the first video in BC Calculus on power series. So we're going to begin with the definition of what a power series is. So there are two different forms in which the sigma notation for a power series could be written. It could be written in the form of the sum from n equals 0 to infinity of c sub n times x to the n, and then you see what the terms would look like if you started to write them out. That is very similar to a times r to the n, which is our format for a geometric series. So in fact, what a power series is it's just a geometric series, but it has the variable x in there in place of where our common ratio is. That's where r usually was our common ratio. That's now replaced with an x. But it's still just a representation of a geometric series. Now, if it is of that form where it's x to the n, then that is a power series with the center of the interval of convergence being at 0. The other format for a power series is the sum from n equals 0 to infinity of c sub n, which is usually your first term, times x minus a to the nth power. So when you have x minus a in here, when there's an actual amount, that's usually a number, so it would be x minus 4 or x plus 2, something like that, raised to the nth power. Then that is a power series with the center of the interval of convergence being at x equals whatever that value a is. So today, to begin with, we're going to be looking at different properties of these power series and different ways to write them. So for example, the geometric series, the sum from n equals 0 to infinity of x to the n, if we write out some terms for that, we get 1 plus x squared, plus, and then it would be x cubed, x fourth, x to the fifth, all of that. That is called a power series because it is all terms with a power on them, hence the name. That series is centered at 0 because we only had x being raised to the nth power, and the interval of convergence is going to be from -1 to +1. And so what we've previously done with finding the radius and interval of convergence for a geometric series, that's going to apply to power series problems as well. So we're going to be looking at in the videos for this section how to find interval and radius of convergence for a power series. Okay, so for example, one thing you should remember is that if we have an infinite geometric series, remember the formula for the sum of it is a over 1 minus r. That formula basically helps us come up with the formula for the sum of any geometric series, and then the formula for that sum is then the function that represents the power series. So for example here, I have the sum from n equals 0 to infinity of x minus 2 over 6 raised to the nth power. This is the sigma notation for a power series. If I wrote out some of the terms of it starting with n equals 0, I would have 1 plus x minus 2 over 6 to the first plus x minus 2 over 6 to the second, and so on and so forth, like that. Okay? To find the common ratio, just like we did with geometric series, we would do 2 consecutive terms divided together. So even though our first term is a 1, we can still use it to find our common ratio. So if we do the second term divided by the first term, our common ratio is x minus 2 over 6. And our first term is the number 1. So using that sum formula up there, the sum would be the first term divided by 1 minus the common ratio. That's the function notation for our power series. However, you're never going to write it like that. Like, they're not going to write it as a fraction written inside of a fraction. So once you use that sum formula for an infinite geometric series to come up with the function, you then want to use your algebra skills to simplify it to where it is a basic single thing in the numerator, single thing in the denominator fraction. So to do that, I would get rid of the fraction in the denominator by multiplying everything by 6. Well, if I'm going to multiply the denominator by 6, I need to multiply the numerator by it also. So when you do that, you get 6 over 6 minus x minus 2. So then that becomes 6 over 6 minus x plus 2, or 6 over 8 minus x. So the function notation for our power series is 6 over 8 minus x. So in all actuality, if I was to graph the function 6 over 8 minus x in my calculator, and then if I was to write out a bunch of terms for this series and put them in my calculator, they would both graph the same thing. These represent the same function. The one up at the top, though, written in red, is just a whole lot more expanded out there. So that's basically the concept of a power series represented as a function. So a power series, in terms of convergence, it will always converge. It's either going to converge for all values of x, which would mean that your interval of convergence is negative infinity to positive infinity, and your radius of convergence is infinity, or it will converge on a finite interval with the same center as what the series has. So maybe like from -1 to +1 or something like that. Or it's only going to converge at that center value. So it may be, for example, that your center is at x equals 2, and that's the only value of x that will give you a series that converges. So the radius of convergence would be 0. And the interval of convergence would just be x equals 2 or whatever it is that your center is. Okay, so for a power series that's centered at a value c, one of those three things is true, and that's kind of explained for you in the box right there. But that sentence up at the top really kind of breaks down what's in the box there for you. So for the last example, we had a radius of convergence of x minus 2 over 6, right? So all geometric series are going to converge if that common ratio, if the common ratio is less than 1. So it's actually the absolute value of the common ratio that needs to be less than 1 in order for the series to converge. So if you remember doing these with the geometric series previously, we then split that up into a compound inequality. And then we solve for x. And everything that we do to solve for x, we have to do it both to the -1 and to the +1. So I would multiply 6 to both of those, and then I would add 2 to both of those. That is now my interval of convergence from -4 to 8. The question is, though, can I actually use those endpoints and also have a power series that would converge? So if you remember from geometric series, we have to check the endpoints. So x equals -4, for example, if we go to the sigma notation that we had for our series, it was x minus 2 over 6 raised to the nth power. So this would be -4 minus 2 over 6 raised to the nth power. So if we simplify that, we would have -1 to the n. And the absolute value of the common ratio there is 1, which is greater than or equal to 1, not less than 1. So therefore, this one would diverge. So we do not actually keep -4 as part of our interval. And then if we do the same thing with 8, we have the sum from n equals 0 to infinity of 8 minus 2 over 6 to the nth power. That's the sum from n equals 0 to infinity of 1 to the n. Again, that r value is equal to 1. It's not less than 1. So this guy would also diverge. So our overall interval of convergence is from -4 to 8. The radius of convergence then, if you remember, we do end minus beginning divided by 2. So the radius of that convergence is 6. And if you wanted to know the center of convergence, it would be the middle of 8 and -4. So you could add them and divide by 2, but you could also go back and look at the structure of the expression. It was x minus 2. So the center is x equals 2. Okay, so that means that as long as you choose an x value between -4 and 8, but you don't actually use the number -4 or +8, then this series right here would converge. Okay, so the next thing that we're going to do is we're going to do the opposite of what we had done originally. You're going to be given a function that's in the form a over 1 minus r, and you have to come up with the power series for it. So you first have to get the function into the form a over 1 minus r if it does not look explicitly like that. Like it has to be a 1 minus in the denominator there. And then to write it as a power series, we would just extract the a and the r from it and apply those to our formula, general formula for how we write sigma notation for a power series. If the power series is not centered at 0, then where we would have x to the n, we'll replace it with x minus c to the n. So this might not make very much sense until we actually apply it to a problem. So here we have example 2. We're given a function that would represent a power series. Now we want to be able to convert that into sigma notation. So we need to extract from here a value for a and a value for r. Now notice here, this says 1 minus, which is exactly what I want it to say. Since that's in 1 minus form, then I immediately know that this is my a and this is my r. Okay, so then my sigma notation for my power series is going to be the sum from n equals 0 to infinity of a times r to the n. That's your power series. That's all you have to do. Then to determine the interval of convergence, you take that r, and put the absolute value of it less than 1, which would mean that your interval is -1 to +1. Now I'll go ahead and tell you for the sake of time, if you check your two endpoints of -1 and +1, they create -1 to the n and +1 to the n, which we saw in the last example would be geometric series that diverge. So we don't actually include them in our interval of convergence there. So the power series itself is this, and then here's your interval of convergence. So in the next video, we're going to look at function notations that are not in our very simple a over 1 minus r format and how to convert them into that format so that then we can write the sigma notation for the power series.